Hi, you should have out section 6-6 notes on rational exponents. Right off the bat, I want you to pause the video and I would like you to do these problems as a warm-up to review the exponent rules. Okay, so hopefully you did that. On the first one, when you are multiplying and the bases are the same, remember you add the exponents. So we get x to the 7th power. On the second one, when you are dividing and the bases are the same, remember this would have an exponent of 1. So you subtract the exponent, so we get m cubed. Or you can think of this as canceling one m out of the bottom with one of the ones in the numerator. Remember that a negative exponent means reciprocal. So you're going to flip this and make it 1 over x squared. We're still going to have negative exponents today, and you need to remember a negative exponent means reciprocal. Power to a power, we multiply the exponents. Remember, there really is a 1 here. So you're going to have 3 squared, which is 9. And then we get x to the 8th power, because power to a power, you multiply exponents. And this one you haven't seen before. These are rational exponents, and they're going to mean something we're going to talk about today. But you already know that if you're multiplying and the bases are the same, then you add the exponents. They have a common denominator already. 3 halves plus 5 halves is 8 halves, which would just be 4. So we get m to the 4th. So that's what you should have gotten. What I would like you to do next is evaluate 16 raised to the 3 halves power on your calculator. So you can do that by just going 16 and then the little caret key to the 3 halves power. You can do a fraction or just do 3 divided by 2. And notice you get 64. So 16 to the 3 halves power equals 64. Well, how do you get that without a calculator? How does that make sense? And that's what we're going to talk about today. So when you have something like this, when you have a fraction exponent, the bottom number tells you to take a root, and the top number tells you to take a power. So think of it like a root cellar is in the basement, so it's down in the denominator, so that's the root, and the numerator then is going to be the power. So think about what would happen if you took the root is 2, so if you took the square root of 16, notice that you get 4, and then if you did 4 raised to the 3rd power, 4 times 4 times 4 is 64. That's all this is. The denominator is the root, the numerator is the power. Now you could also do 16 to the 3rd power, and if I do that, 16 raised to the 3rd power, I get 4,096, and then take the square root of 4,096. So if I do that, I also get 64. So the order doesn't matter. You could either do it the way I did it first or this other way, but I do want you to notice something. When I did the root first and then the power, I didn't need a calculator because I could do that in my head. When I did the power first and then the square root, I don't know that. I had to use a calculator. So it's kind of nice if you can take the root first. If this is if you can evaluate the root, then it will make it a little easier. This is just kind of talking more about that. So if you see, it's not just for square roots. If you see something like 27 to the 1/3 power, then again, this is the root and this is the power. So that's just the cube root of 27, and then it would be to the first power. So you wouldn't need that. It's just the cube root. So if there's just a 1 on the top of your fraction, then it's just the cube root in this case. And this would be the square root of negative 16, which is going to be a complex number, so you get 4i. So one of the things you're going to need to know how to do is to switch things from exponential form to radical form. This would be exponential form because it's written with an exponent. And we want to switch it to radical form. So remember, this is just the root and the power. So we just get the 7th root of a. And that would be your answer. You can put the 1 there if you want to, but you don't need to. And then to write the square root of w in exponential form, if you want to put a little 2 there, you can. So now we're going the other way. We're going to exponential form. So the base is my radicand, what's underneath the radical sign, and it's the first power, and then the root is a 2. So that would be my answer. So these aren't hard. It's just knowing what to do. So go ahead and try this example. So you can pause it and try the example. You should have gotten C for this one. And go ahead and write this in exponential form. So go ahead and pause it. Okay, you should have gotten A, x to the 1/5 power. All right, so they're not hard. So this next example, we're evaluating expressions with rational exponents. So a couple things I want you to remember here. Now, the 2 is the root. So I'm going to take the square root of this 49. And the power is a 1, so I don't have to do anything there. So I'm taking the square root of 49. But the negative power, remember, it doesn't mean the answer is negative. It means reciprocal. So that means I'm going to take the square root of 49, which is 7, but I have to do the reciprocal, so I get 1/7. Now, you should be able to do that in your head, but you can always do this. 49 raised to the negative 1/2. Now, it will give you a decimal approximation. I guess I could have switched it to a fraction, or you can just do 1/7 and verify that it's the same. But again, you can do that in your head. Remember that the negative means reciprocal. On this next one, evaluating 32 to the 2/5. Remember, you have a choice. If you think about what this means, this is the root, this is the power, and think about what would you do first. Well, you don't want to do 32 squared because that's going to be a large number. But the 5th root of 32, this is one. Some of you may know this, some of you might not, because we work with powers of 2 a lot because they're easy to work with. So the 5th root of 32 is 2, and 2 squared is 4. So you can work it out by taking the 5th root first. So what I did was the 5th root of 32, and I got that answer, and then I squared that answer and got 4. So I did it in those 2 steps. Check your answer by going 32 raised to the 2/5, and you'll see you get that answer. Okay, but again, on ones that you can work them out easily, try it without a calculator. Okay, so go ahead and try this one. So pause it and try it. All right, so we're taking the square root of 25, which is 5, but it's reciprocal, so you flip it over and get 1/5. So hopefully you got that. Remember, it's not negative. Sometimes people get confused on that because they see this negative sign, so they think this is negative, but remember the negative sign means reciprocal. Go ahead and pause it and try this one. All right, so if you take the 4th root of 16, you get 2, because 2 to the 4th power is 16, and then take that 2 and cube it, and you get 8, so that is the answer. All right, I've already taught you this. So this is just showing you that, because the other examples were where you just had a 1 on the top. So this is just showing and explaining that you would take the cube root of 27 and then square it. Right here, we would take the square root of negative 16, which would be 4i, and then you cube it, which would be, if you cube 4i, and then you cube the 4, so you get 64. That's where the 64 comes from. And then you get an I cubed. So you might wonder, well, where'd this come from? Where'd they get this negative 64i? Well, remember, we had a pattern here. Remember that I squared is negative 1. And we had a pattern that went, well, I'll just tell you. If you have I squared times I, you get I cubed. So then that's just, remember, I squared is negative 1. So negative 1 times I is negative I. So that's why they have a negative 64i. So they're just simplifying the I cubed part. So this next problem, the formula m equals 512 minus 146,230 times b raised to the negative 8/5 can be used to estimate the maximum total mass that a weightlifter of mass b kilograms can lift using the snatch and the clean and jerk. if I were in class, I'd either show you what that is talking about, or I'd have a weightlifter in our class demonstrate that for you. Google it if you want to know. According to the formula, what is the maximum that a weightlifter weighing 168 kilograms can lift? So we need to know what we're plugging this in for. So this is the mass of the weightlifter. So estimate the maximum total mass. So the mass of the weightlifter is B. So we're going to do M equals 512 minus 146,230 times 168 to the negative 8/5. So this is the problem that we're going to work out. Now, I don't know what the fifth root of 168 is. It might not even be it might not even work out nice, but this is one that I wouldn't even bother. I would actually use my calculator and say 512 minus 146,230 times 168 raised to the negative 8/5. And when you do that, you get approximately 471.8, and this would be kilograms. Okay, so not a hard problem to do, and you're just going to use your calculator to evaluate that. And this one is just plugging in a different amount. You can do that if you want. I'm not even going to bother going over that because you're just plugging it into your calculator. All right, so this next example, again, we have the gigantic times sign. We saw that once before, but this is just multiply. It is not any special symbol. So I am multiplying and the bases are the same. So remember, the rule is to add the exponents. So then, they already have a common denominator. That's convenient. So we get y to the 5/7, and we would just leave it like that. On part B, to be in simplest form, you are not supposed to have a negative exponent. So remember that this is reciprocal. So I'm going to start by doing 1 over x to the 2/3 because that's the reciprocal. However, I want to remind you that this right here is like having 1 over the cube root of x squared. So, because that's what that means. The 3 is the root, the 2 is the power. So we get this. Well, if you remember from the last section, we're not supposed to leave a radical in the denominator. So I need this, since this is a cube root, I need this to be x cubed. So I'm going to need to multiply by the cube root of x. I needed one more. So now, and I'm going to put a power of 1, because now if I multiply these together, I get the cube root of x cubed, and that's just x. But whatever you do to the bottom, you have to do to the top. 1 times the cube root of x is the cube root of x. So my answer is the cube root of x, and this is just going to be an x now because it's the cube root of x cubed. And because my problem initially had a rational exponent, I'm going to switch it back to that format with a rational exponent. So this would be my answer in simplest form. And I know you might look at that and say, well, this looks simpler. But technically, to be in simplest form, we're not supposed to leave a negative exponent, and we're not supposed to leave a radical in the denominator. Now, let me show you without having to go through all that. Let me show you another way to think about this. I want this to be x to the 3/3 because 3/3 is 1, and I just want it to be an x. So think about, what do I add? What do I add to 2/3 to get 1, to get 1 whole? Well, I need another third, right? 2/3 plus 1/3 is 1. Whatever I do to the denominator, I do to the numerator. If you add the exponents, you're just going to get x to the 1st. And here you're multiplying, and you get x to the 1/3. And there's my answer without going through that. I wanted to go through this because It's something you were already familiar with, we've talked about, but I actually find it easier to do it this way and just think about what fraction I would need to make it a whole number so that I can use that instead. And I find that a little easier to do. Go ahead and try this one, pause it. When you add the exponents, you should have gotten 3/5, so x to the 3/5. Go ahead and pause this one. Really try it. I know this one's a little harder. Okay, so start by thinking reciprocal. So 1 over y to the 3/4. What would you need to multiply by to complete this and make it a whole? We'd need y to the 1/4. Whatever you do to the denominator, you do to the numerator. So I get y to the 1/4, and now I have y to the 4/4, which is just y. So that is this one. Okay, so hopefully that helps. Okay, so on this next one, notice that they are not the same roots. I have a cube root, I have a 6th root. So this is what we're going to do. We're going to break that 16 down, and we're going to make this prime numbers, because we can write this as powers of 2. So I can think of this as 8 times 2, and the 8 breaks down to 4 times 2, and the 4 breaks down to 2 times 2. So notice I have 4 factors of 2. So this is 2 to the 4th power. So I'm going to think of this as the 6th root of 2 to the 4th power. And here I have the cube root of 2 to the 1st power. I'll put a 1 there. Now I'm going to rewrite these as fractions. So remember, the root goes on the bottom, the power goes on the top. So I get 2 to the 4/6, because the 6 was the root, the 4 was the power. I get 2 to the 1/3. Well, notice that this can be simplified. 4/6 reduces to 2/3. And I still have a 2 to the 1/3. We're dividing and the bases are the same, so I subtract my exponents. And conveniently enough, they're already common denominators. So I get 2 to the 1/3. And that's fine if you leave your answer like that, but because my problem was given to me in radical form, I like to write my answer in radical form. So I would write my answer like this, but I would accept 2 to the 1/3 as well. So just as a reminder of what we did, I broke the 16 down into prime factorization so I can simplify something. Then I wrote it with rational exponents. If I could simplify the fraction, I did. The bases are the same, so I subtract the exponent. That was just our rule for dividing with exponents. And then once I do that, and sometimes the denominators aren't the same and you have to do some work with fractions, but then you get your answer. Okay, for this one, same kind of idea. I'm going to break that 4 down and think of it as 2 squared. So I'm going to think of this as the 6th root of 2 squared, and this is times x to the 4th. So now remember, 2 is my power, 6 is is the root. So I'm going to have 2 to the 2/6 times x to the 4/6. Reduce the powers, so reduce the fractions, and we get 2 to the 1/3 times x to the 2/3. And I would be okay with you leaving your answer like that. But if you wanted to put it back into radical form, notice they both have a root of 3, which means I can put them under the same radical. I have 2 to the 1st power, which is just 2, and I have x to the 2nd power. So this would be my answer. So again, I broke that number down so that I could rewrite it with a power. I rewrote them with fraction exponents. The root goes on the bottom. Reduce the fractions if you can, and that would have been fine if you left your answer like that. I chose to put it back in radical form. Okay, this is the toughest one. Well, like it is, because it looks really complicated. Rewrite this in radical form. So the 1/2 power is the square root of y. And then down here we have the square root of y minus 1. We've done these before. And the idea on this one is you have to multiply the top and bottom by the conjugate of the denominator. So we're going to multiply by conjugate of denominator, which would be the square root of y plus 1. To get the conjugate, you just change the sign in the middle. And then you could multiply it out, put it in a box. So if you FOIL this in the top, you're going to have the square root of y times the square root of y is just y, because you're squaring a square root. Then the outside, I'm going to put it in a box over here. So we have the square root of y plus 1, the square root of y plus 1. So here I get just y, because I'm squaring a square root. Here I get 1 times the square root of y, 1 times the square root of y, and 1 times 1 is 1. So I get y plus 2 times the square root of y plus 1. And in the denominator, if you multiply that out, if you do the square root of y times the square root of y, you get y. The outside, you're going to get a positive square root of y. The inside, you're going to get negative square root of y, so those will cancel out. And then the last, you're going to get negative 1. And this is actually your answer. And once again, you might look at that and say, okay, this doesn't look that simple, but notice I no longer have a radical in the denominator. And it would be okay to write it as y plus 2y to the 1/2 plus 1 over y minus 1. That's okay to do that. So anyway, that's what we would have. I actually do problems like this in radical form. A lot of problems I'll switch to rational exponents, fraction exponents, because they're easy to work with. But a problem like this, I actually do it this way with radicals. I find it easier, so you might find that easier as well. Okay, so pause it and try it. I know these are a little harder, so pause it and try it. Okay, so on this one, if you break that 4 down to 2 squared, remember this is a square root. So then we're going to have 2 to the 2/4 over 2 to the 1/2, and this reduces to 2 to the 1/2. I hope no one tells me that this answer is 0. They didn't even give you that as an option. If I were doing a multiple choice test, I probably would have, and I know that would be mean. If you follow the rules for exponents, 1/2 minus 1/2 is 0, so you get 2 to the 0 power, but you got to remember anything to the 0 power is 1. And think about it this way, when you divide something by itself, they cancel and you get 1. So the answer is actually 1. Okay, so pause this and give it a try. Okay, so we're going to break that 16 down, and when you do, you will get 2 to the 4th power. So we're going to have 2 to the 4/6 times x to the 2/6. Remember, the 6 is the root, so it goes in the bottom. Reduce the fractions. And notice my answer choices all have radical forms. So because they both have 3's for the base or for the root, we can, or not the base, I shouldn't say, the denominator of the fraction. So we have a cube root. 2 squared is 4, and then we have an x to the 1st. So we get, you should have gotten A. Go ahead and pause this and give it a try. All right, so if we have the square root of x minus 1 over the square root of x plus 1, multiplying by the conjugate would be the square root of x minus 1, because you change the middle sign. In the numerator, if you put this in a box, you're going to get x minus 2 root x plus 1. If you put the denominator in a box or FOIL it, you're going to get x minus 1. And that would be fine to leave your answer, but notice that they have switched it. So if I was going to find which one matches, it's going to be this, which is choice A. So then, just as I think this is the last slide. How do you know if it's completely simplified? You cannot leave any negative exponents to be simplified. Okay, no negative exponents. Remember, a negative exponent means reciprocal. It has no exponents that are not positive integers in the denominator. Okay, that's like negative exponents, right? It is not a complex fraction, so you can't have like a fraction over another fraction. You have to work those out. The index of any remaining radical is the least number possible. What that means, the index is the little, like if you had 4x squared, they're saying you can't leave this because this can be simplified. X to the 2/4 would be x to the 1/2, which is the square root of x. So you can't leave this because that's not the smallest index possible, because you can rewrite this and simplify that and have just the square root of x. That's what that last part means. So this little statement is what I did in the examples. Okay, I think that should cover it. So you should have enough examples. Remember that you can also look at examples in your textbook, and you can also watch the personal tutor videos that are on your electronic textbook. So don't forget about those resources that are available to you as well.